Hello, good afternoon, students. Today we are going to start with magnetism. Okay, in yesterday's lecture, what we have studied? We have studied about the electric circuit. Okay, so what is electric circuit? Electric circuit is nothing but it is a closed loop. Okay, what is circuit? A circuit, anything which is closed. Okay, it forms a loop that is known as a circuit, and when electricity passes through it, it is known as an electric circuit. So first of all, what was electricity? The current. Okay, and what is current? The current, it is the flow of electrons, or you can say it is a flow of charge. Okay, next was the voltage definition. The potential difference between any 2 points is known as a voltage. Okay, now in today's lecture we are going to study about the magnetism and electromagnetism. So what is the basic difference between the two? The basic difference is that magnetism or magnetic or magnets, it refers to the magnetic fields. Okay, it refers to the phenomena which is associated with the magnetic fields or magnetic forces. Okay, but what is electromagnetism? It is one type of magnetism, but here what is happening? It is produced by the electric current. Okay, and as the name suggests, electromagnetism, they are associated with both the magnetic circuit, magnetic fields and electric fields. Okay, so this is the key difference between magnetism and electromagnetism. So first of all, we are going to concentrate on magnetism. In first, or I think so in second lecture, we have studied the terms, okay, related with magnets. So what were those terms? In the first slide, I have shown you the lines. The magnet was shown and lines were also shown. Okay, so the lines is nothing but what were they? They were the magnetic fields. Okay, what were they? They were magnetic fields. They are also called as magnetic flux. Okay, these definitions we have studied already, that what is magnetic flux, what is magnetic flux density. Okay, what is flux density? It is denoted by capital B. Okay, and the formula for it was phi upon A, that is flux upon area, and the unit was Weber per meter square. Okay, so this was related with the magnetic flux density. So in this slide we are going to study more terms related with the magnetism. Okay, so this is the magnetic permeability. So what do you mean by magnetic permeability? It is the magnetic permeability, it is directly proportional. Okay, it is directly proportional to the number of lines passing through it, and the permeability, this value this value is constant. The permeability of the air or vacuum, it is equal to 4 pi into 10 raised to minus 7 Henry per meter. Okay, first of all, the every medium, okay, every medium consists of a certain property. Every medium consists of certain property which is known as permeability. Okay, which is known as permeability. So even it may be magnetism or electromagnetism, they both depend upon a certain property of the medium which is known as permeability. Okay, and this permeability, they consist of two. Okay, permeability, it consists of two. One is absolute permeability and the second is relative permeability. Okay, first is absolute permeability and the second is relative permeability. And the permeability is designated, okay, or it is denoted by mu. So see this, this is mu, okay, and it is defined as, it is also defined as the ratio of flux density to the magnetic field density, okay. It is defined as the ratio of magnetic flux density to the magnetic field density, that is B upon H, okay. Always remember this, that the permeability, it consists of two, okay, or it is divided into two, you can say. One is absolute permeability, which is denoted by mu 0, and it is always equal to, that this is constant, 4 pi into 10 raised to minus 7. And second is the relative permeability, okay. This is the formula for it. See this, where B is the magnetic flux density and H is the magnetic field strength. Now here we are going to start with our magnetic circuit. Okay, so the closed path, the closed path followed by magnetic lines of forces or flux is called as a magnetic circuit, okay, or in other words we can say it is defined, okay, it is defined as the route or path which is followed by a magnetic flux. Okay, in the last lecture, what we had studied, that electric circuit. What was electric circuit? It was also a closed path. Okay, what it was? It was a closed path followed by what? Lines of charges. So the continuous path followed by the charges was known as an electric circuit. Okay. Now what is this in magnetic circuit? What we are saying, that the closed path, okay, the closed path followed by magnetic lines of forces or flux. Okay, magnetic lines म्हणजे काय? They are nothing but the flux. Magnetic lines of fields म्हणजे काय? They are nothing but the flux. It is called as a magnetic circuit. Here we are taking one. See this. Huh? What is this? This is an solid iron ring. Okay. What is this? This is an iron ring. हे काय दिसते तुम्हाला? आयर्न रिंग आहे. आणि हे कशापासून आहे? तर हे सॉलिनॉइड आयर्न रिंग असं आपण त्याला म्हणतो. ओके. आता याच्यामध्ये काय दिलेले आहेत? हे जे दिसतात तुम्हाला, हे काय आहेत? दीज आर द नंबर ऑफ टर्न्स. हे वायर आहेत. दीज आर द नंबर ऑफ टर्न्स. आणि इथं आपण काय केलेलं आहे? ह्याला सप्लाय दिलेला आहे. ओके. आणि हा जो पूर्ण ह्याचा जो सर्कम्फरन्स आहे किंवा हा पूर्ण आयर्न जो आहे त्याला आपण काय दिलेला आहे? त्याची लेंथ काय दिलेली आहे? तर इट इज एल. ठीक आहे. हा जो आहे त्याचं काय आहे? दिस इज द एरिया. आणि हा जो आपण आता ही वायरची आहेत ना, त्याला एन म्हणालोय. दॅट इज द नंबर ऑफ टर्न्स किती आहेत. ठीक आहे. आणि नेक्स्ट काय आहे? तर आता हे जे आपण डॉटेड लाईन्स दिसतात ना, ही सगळी, ही काय आहे? दिस इज द मॅग्नेटिक लाइन्स और मैग्नेटिक फोर्सेस और मैग्नेटिक फील्ड्स. फायनली त्याचं नाव काय आहे? तर फ्लक्स. ओके. सो नाउ लेट अस कन्सिडर अ सॉलिनॉइड रिंग, आयर्न रिंग, having a magnetic path of L meters. ठीक है. Area A is the cross sectional area. It is in meter per meter square. त्याच्यानंतर the number of turns, N is the number of turns which is carrying I, that is the current. Current in amperes. Okay. Here we are having mu r. म्हणजे मगाशी आपण मागच्या स्लाइड मध्ये सांगितलं होतं ऍब्सोल्यूट परमेबिलिटी आणि रिलेटिव्ह परमेबिलिटी. त्यातला mu r is the relative permeability. Okay. So now the magnetic flux. Okay, magnetic flux is having what unit? Weber. So let us say that the phi is the flux having Weber, which is set up in the core, and when the current I ampere passes through it, what is happening? What is happening? The magnetic flux density is set up. Okay, what is happening? The magnetic flux density is set up in the core. And what is this magnetic flux density? It is nothing but the flux passing per unit area. Flux passing through unit area at right angles to the flux. Okay, and so it is designated by B, capital B. Now, as I have said earlier, that the poles, the poles are strong. They are also known as magnetizing force, magnetizing field strength, that is H. So what is H? H is B upon mu 0 mu r. In this third slide, I have shown you that mu is equal to what? It was B upon H. Okay, so what is happening here? H is equal to B upon mu 0 mu r. Okay. Now here what we are doing, we are substituting the value, the equation of B is equal to phi upon A in this equation. So the magnetizing force H is equal to what? It will be B upon A mu 0 mu r. Okay. So according to the work, the law, the work done, the work done in moving a unit pole around the magnetic circuit is equal to the ampere turns enclosed by the magnetic circuit. हा इकडे आला HL. HL is equal to N into I. Now here N is the number of turns and I is the current. I is the current. H into L is equal to N into I. But what is the value of H? आता आपण मगाशी लास्ट स्लाइड मध्ये बघितलं, इट वॉज phi upon A mu 0 mu r. तर आता आपण याच्यामध्ये ती व्हॅल्यू सबस्टिट्यूट केली. नंतर हा जो आहे L तर आला इकडे. सो नाउ H is equal to N into I. So finally what we are getting, phi is equal to Ni upon L, divided by A mu 0 mu r, where mu is the permeability, mu is equal to mu 0 mu r, which is the absolute permeability. त्याच्यानंतर काय आहे, relative permeability is equal to mu r. आता ही जी टर्म आहे ना, एक रिलक्टन्स, रिलक्टन्स, ती काय आहे, ही जी पूर्ण टर्म आहे ना, दिस इज द रिलक्टन्स L upon mu A. So here we have the definitions. So MMF, MMF is what? MMF is the magnetomotive force, and it is required to drive the magnetic flux in the circuit. Its unit is ampere turns. Reluctance. What was reluctance? It is the property of the material which opposes the flow of magnetic flux in it. आणि resistance चा काय होता definition? It was the property of the material which opposes the flow of current. आलं लक्षात? हा काय आहे? Reluctance काय आहे? It is the property of the material which opposes the flow of magnetic flux in it. It is denoted by S आणि त्याचा unit काय आहे? Ampere turns per Weber. Next काय आहे? Permeance. Okay, what is permeance? It is defined as the reciprocal of reluctance and it is measured in Henry or Weber per ampere turns. And permeability, it is defined as the property of the material. Okay, it is defined as the property of the material to allow the magnetic lines of forces to pass through it. It is denoted by mu, and as I have said earlier, there are two permeabilities. One is absolute permeability and second is the relative permeability. Okay, and it is denoted by mu r. Now in this slide we are going to study the difference between the electric and magnetic circuit. So first, uh, all of you have to write down this. Okay, this is your note and this comes for 4 marks. Difference between electric and magnetic circuit, or it may also come for 2 marks in question number 1. Okay, so see this. Uh, there are 4 columns. One is serial number, characteristics, electrical circuits and magnetic circuits. Okay, the first basic difference is in an electric circuit, the current always flows through the path. Okay, and in the magnetic circuit, the magnetic flux flows through the path. It also flows through the path, but both these are closed path. Okay, what are they? They are the closed path. Now write down the definition of electric current. The number of free electrons or electric charge particles which moves in the circuit is called as electric current. It is denoted by I. Okay, and the unit is ampere. The unit is ampere and the formula is I is equal to V upon R, or it is also known as EMF upon the resistance. What is R? R is the resistance. And in magnetic circuit, the number of magnetic lines of the force passing through a magnet is called as a magnetic flux. Okay? And it is denoted by phi. Its unit is Weber. Next is the circuit. Okay, in this circuit, the electric current flows from positive to negative polarities, whereas in magnetic circuit, what is happening? The flux always flows from north pole to south pole. And this next is force. Okay, the force is necessary to move the free electrons in particular direction and also produces the current. This force is called as a electromotive force. It is denoted by EMF. Okay, and the unit is V, that is volts. Magnetic circuit is the force is applied to the number of magnetic field lines passing through the surface, and this force is called as a magnetomotive force. It is denoted by mmf. Okay, and the unit is ampere turn. Next is the properties of the substance which opposes the flow of electric current is called as a resistance. And in magnetic circuit, the properties of the substance which opposes the flow of magnetic flux are called as reluctance, and it is denoted by S. Okay? In electric circuit, the resistance formula is rho L upon A, where rho is the specific resistivity. It is called as specific resistivity. And in magnetic circuit, the formula for reluctance is L upon mu A, where mu is the permeability. Here One more is the conductance. Okay, what is conductance? It is the reciprocal of resistance. It is the reciprocal of resistance. And what is permeance? Permeance, it is the reciprocal. Okay, it is the reciprocal of reluctance. That is 1 upon reluctance is the permeance. Okay, next, these were the difference between electric and magnetic circuit. Okay, like or you can say, to be more precise, this is the comparison of electric and magnetic circuit. Okay, so if it is given in the question, write the similarities between electric and magnetic circuit, you can write this, because like, what are the similarity? The path of the current is called as electric circuit. In magnetic circuit, what you can write? The path of the flux is called magnetic circuit. Then current, in electric circuit, current is equal to EMF upon resistance. Okay, and in flux, that is in magnetic circuit, MMF upon reluctance is the flux. Okay, so this is the similarities also, and you can say difference also. All of you should write this down. Okay, and more addition to this is, in electric circuit, write down that current actually flows in the circuit, whereas in magnetic circuit, you can write it as flux does not flow in a magnetic circuit. Okay, in electric circuit, write down resistance of the current is independent of the current, resistance of the circuit is independent of the current. And in magnetic circuit, write down reluctance of the circuit changes with the magnetic flux. Okay, so you have to write down this. And this question, it always comes to your test, or you can say in exam. So go through it, and it may come for 4 marks or it may come for 2 marks. Okay, thank you.